Okay, the last question we need to answer is, when the ball is caught by Aaron, what's the distance between Aaron and Chase? So we're looking for this distance right here. Now, the thing that we know so far is that it took a second to reach this peak. And of course, we know that it takes a second to come down. It took a second to go up, takes a second to come down. So the total time of flight is equal to the time to get here will be 2 seconds. We also know that the velocity in the x direction is going to be constant throughout the flight, and we know this because, well, because we're ignoring a whole bunch of real things. We're pretending like they don't matter. So we're pretending like, for example, let's see, did we say change the ball when the ball leaves, traveling, yada yada yada. Okay, here we go. There's not enough wind or air resistance to cause the ball to decelerate or change direction. So we're pretending like the horizontal velocity that Chase imparted by throwing this ball is going to be the same at the very end. It's the same throughout. So we can use that. We know that the distance x final is the initial distance plus the velocity in the x direction, which we know to be, now this sign, we know now that the cosine of 30 is equal to the adjacent side over 2, or is equal to the square root of 3 over 2. 2 is, of course, the hypotenuse, so the cosine is the adjacent over the hypotenuse. So let's see, we've got here now that this Vx is equal to the square root of 3 over 2 times the 20 meters per second. Okay, so you realize I've skipped over the geometry, knowing that you would have to understand how to break down this vector in 20 meters per second squared into the x direction and the x component and the y component. So now using the x component, I know that the acceleration, a t squared over 2, I know that this term goes to 0 because there's no acceleration in the x direction. I know this term goes to 0. So we're just left, oops, I left out the time. We're left with this simple equation, x final is equal to the square root of 3 over 2 times 20 meters per second times 2 seconds. And that is about, I don't know, okay, I'm going to have to do that in my head. Okay, this is going to cancel. This is going to be 10 times the square root of 3. 10 to, oh, okay, or this, again, 20 times the square root of 3. 20 times the square root of 3. See, the square root of 3 is, what is that? 1.4? Or is it 1.7? 1.4 or 1.7? Well, let's see, I can't remember. 117, I think it's 1.73. Let's see, 1279071. I can't read my own writing. 1, 2, I think that's a 2. No, that's a 7. I know 6. 1, 2, 6. So yeah, it's 1.7 something. Okay, so 17, square root of 3 times 10 is going to be 17 times 2 is going to be about 34 meters. The seconds should cancel. So 34 meters again in, if I were looking one significant figure, that would turn into approximately 30 meters. I like to keep this extra significant figure. I don't know, it makes me feel better. So we've got the distance is 30 meters, or 34 meters if we kept the extra significant figure.